Hi everyone, here we are going to presenting about the COA presentation or increment or decrement counter. Myself Lakshmi BV.
I am Zainab Sodagar.
I am Tamanna.
I am Tanaz Banu.
Next slide. And the my part is abstract. This experiment demonstrates the use of assembly language programming to design an increment or decrement counter where a value stored at memory location 84H is incremented from 00H to 0AH, then decremented back to 00H using the increment and decrement instruction. This program showcases how data moves between memory and CPU registers such as the accumulator and general purpose registers during each operation. It emphasizes the importance of assembly language in performing low level CPU and memory tasks efficiently, highlighting how simple instructions can achieve precise control, optimize execution, and straighten understanding of hardware level program. Next slide.
Introduction. An increment and decrement counter is a type of sequential circuit used to count up or count down a sequence of a binary numbers. It forms a critical part of a digital system, playing an important role in operations like addressing sequence, instruction execution, and loop control. An increment decrement counter can increase or decrease its a binary count value by one or each clock pulse depending on the control single processed. Next slide.
I am going to explain the problem statement about this project. The first point is increment loop scenario. Counter at 84H cycles to 0.00AH task. Increment till 0AH. Counter starts at address of 84H. The task is to increment from 00H up to 0AH. This means you are writing an assembly program likely for the 8085 microprocessors that repeatedly increments a register or a memory location. Each time the loop runs, increases by 1 until it reaches 0AH. The increment instruction increases the contents of the register by 1. Second one is decrement loop. Now you start from 0AH and keep decrementing until you reach 00H. Each time the loop executes, the accumulator decreases by 1 unit. It becomes 00H. The decrement instruction decreases the contents of the register by 1. Third one is show memory register sequence. Include accumulator and general registers. You are expected to show how the register value like A, B, C, etc. and memory changes step by step during the increment and decrement operation. This shows the step-by-step data through register during the execution. Fourth one is explain instruction choice. Why use of increment or decrement instruction is used. Increment and decrement are single byte instructions. They do not affect the carry flag, which is beneficial for small counter loops. They are faster and simple for increment decrement operation compared to using addition or subtraction. For example, increment A is shorter and execute fast than add A. Decrement A is simple than subtract. Next slide. Objectives of this project are: the first point is to design and implement assembly language program that perform fundamental CPU and memory operation. Assembly language provide a way to directly control the hardware using machine level instructions, allowing programmers to manipulate registers, memory addresses and processor operation precisely. By designing and implementing assembly program, students learn how data is moved between register and memory, how arithmetic and logical operations are executed by the CPU, and how control flow is managed. Second point is to understand and analyze how register, memory and instruction set interact during execution. Register act as high speed storage location within the CPU that temporarily hold data, addresses and intermediate result during program execution. Memory store both program instructions and data that the CPU assesses and manipulate during execution. Third point is to straighten problem solving skill by applying low level programming technique as a loop, conditional jump and data manipulators. Low level programming involve writing instructions that closely correspond to the CPU's machine language, requiring a clear understanding of how data is processed at hard level. Techniques such as loops, conditional jump, and data manipulator help implement logical decision making, repetitive tasks, and direct control over data storage and retrieval. Next slide.
First is increment counter program. Int counter is equal to 0. Initialize counter to 0. While counter less than or equal to 0 into 0, a loop runs until counter less than or equal to hexadecimal. Integer dot to hexadecimal string counter converts counter value into hexadecimal format. Dot to uppercase plus heads converts to uppercase and add heads to indicate hex value. Counter plus plus increments the counter, acts like INC instruction in assembly. This is the output of this program. Next, decrement counter program. When we run this program, this is output. In same as it is, the counter is a decrement. The counter acts like a deck instruction. Both the programs demonstrate increment and decrement operation using simple Java loops. Integer dot to hex string converts number to hexadecimal format. The increment counter moves from 0h while decrement counter moves from AH to 0h. This program helps understand loop control, hexadecimal representation and basic instruction simulation. Next is the memory register sequence. Memory register sequence. This is the program. When we run, this is the output. Initialization section. Memory 84H stimulates a memory location at address 84H. They represent the accumulator, a central register for arithmetic operation. R0 act as a register pointer holding the address 84H. R1 is the another temporary register used to store values. Next, the loop runs while accumulator a less than or equal to 0 ah. Each cycle increments a by 1, moves subset a to register R1, store it back into memory 84H. Display section prints the register and memory values after each increment cycle. Values are converted to hexadecimal to match a microprocessor representation. R0 means constant as it points to address 84H. This is the output explanation. Here R1 and memory 84H increment together showing proper data transfer and memory update per cycle. Conclusion, the program efficiently demonstrates the use of INC instruction, increment operation, data follow between memory and register A, R0, R1. How register memory synchronization works in a simple simulated microprocessor environment. Next, last program is instruction choice demo. When we run this program, this is the output. So A act as the accumulator initialized to hexadecimal value 05H. B is another general purpose register with value 01H. INC equivalent. The A++ statement increments A by 1. Output after this operation A is equal to 06H. Add equivalent adds the contents of B to A, like add a B instruction. Output after addition A is equal to 07H. Decrement equivalent. Here A is a result to OAH. then decrement by 1. Output after decrement A is equal to 0n. Sub equivalent, subtract B from A. Like sub A comma B instruction, output after subtraction A is equal to 0BH. This program shows how different arithmetic and logic instruction used in low-level programming like in 85, 86 microprocessor can be represented in high-level Java. It helps understand how register operations are abstracted in modern programming language.
Next slide, Tanaz.
Conclusion of this project: An, an increment decrement counter is an essential sequence circuit used for controlling and tracking binary operation within a system. It provides an ability to count up or count down automatically based on clock, buzzer, and control signals, making it vertical for timing, sequence, and arithmetic operations. This counter plays a key role in components like program counter, address register, and loop control units, where precise and efficient counting is required. Overall, the increment decrement counter enhance the functionality and perform of a digital system by enabling smooth and reliable